Okay, in this example we need to describe a sequence of transformations which maps the graph of y equals e to the x onto the graph of y equals e to the 2x plus 5. Often when you're describing transformations, you'll find that you tend to use your intuition quite a bit. By that I don't mean there's anything magical about finding these, but you will find that the more experience you have at solving these kind of problems, the more you just start to see the answer to them. So if at first you find you're really struggling to spot the transformations, be assured that given time you'll probably get better at it. So the first thing we want to look for is which letters have been replaced and what have we replaced them with. In the transformed equation we have a plus 5 which we don't have in the original equation, so we think how do we get that plus 5? You may just know that if you see a plus 5 on the end of an equation, that's a translation of 5 units in the positive y direction. If not, you could rearrange to make it y minus 5, and then you can see that y in the original equation has been replaced by y minus 5. So our first transformation is a translation of 0, 5. As we write down each successive transformation, it's good practice to apply that transformation to the original function to see if we actually do get to the answer we want. So here we have y equals e to the x, and if we apply our translation, that's going to be replacing y by y minus 5. And if we rearrange that, we get y equals e to the x plus 5. Next we'll deal with the 2x. To get from x to 2x, we've clearly multiplied by 2. But when we're dealing with stretches, it's easy to think of the scale factor as the thing you divide by. Multiplying by 2 is the same as dividing by a half. So we have a stretch of scale factor 1/2 parallel to the x-axis. Once again we'll apply that transformation. Currently we have y equals e to the x plus 5. And if we apply a stretch of scale factor 1/2 in the x direction, we're going to replace x by x divided by 1/2. Dividing by a half though is the same as multiplying by 2. So we get 2x, and then on the outside the plus 5 as required. So just to recap, a couple of things that are helpful with these kind of questions is first of all, apply the successive transformations and write down the results of them. Don't skip straight to the answer unless you are really confident you've got it right. And the other thing is when you are doing these transformations, always try to think of them as replacements. We did a translation of 0.5, so we replaced y by y minus 5. We did a stretch, scale factor 1/2, and replaced x by x divided by a half, which was like timesing by 2. Here's one for you to try then. Pause the video, and then come back and check your solution against mine. Welcome back. Okay, so I've put the answer on the screen. Compare yours with mine. If you've got the same, great. There's not really anything else to discuss in this question. If you've got the same transformations in the other order, that's fine as well, because we've got one in the x direction and one in the y direction, so the order doesn't affect the result. If you haven't got this answer, make sure you watch the rest of the video so that you can make any necessary corrections. This time we'll first deal with the x plus 4. To get from x to x plus 4, we need a translation of 4 units in the negative x direction. Let's apply that to the original function. To apply a translation of negative 4, 0, we do x plus 4. Next we need to deal with the 3. You might just spot that multiplying the whole function by 3 is a stretch of 3 in the y direction, or you might divide by 3 and spot that y has been replaced by y over 3. Either way is fine. So we have a stretch of scale factor 3 parallel to the y-axis. Let's apply that to our current function. We have y equals log x plus 4. Stretch of scale factor 3 in the y direction means divide y by 3. And if we multiply up by the 3, we get y equals 3 log x plus 4 as required.